Good morning, all of you. Yesterday we were discussing about how conductivity and molar conductivity will be varies with concentration. Yesterday I already explained how conductivity will be varies with concentration, that is directly proportional to concentration. What is the meaning of conductivity? The conductance due to ions present in unit volume of the electrolytic solution. More concentration, more ions, more conductance, means conductivity. Low concentration, less number of ions in unit volume, then conductance will be less. That's why K is directly proportional to concentration. Now we are discussing about the molar conductivity versus concentration. So molar conductivity means what? Conductance due to 1 mole of electrolytic solution. Whatever concentration you will give is not a matter, but due to 1 mole of electrolyte, how much power is passing, that is calling as molar conductivity. So just already we have some idea from its formula. Molar conductivity, if you can take a CGS formula, we have, what is that one? K into 1000 by, what is coming among? C. So from this formula we can get something relation between molar conductivity and concentration, that is nothing but molar conductivity is inversely proportional to concentration of the solution. We have to explain this one, how it is going on. First of all, I am taking 1 mole of NaCl in 1 liter of water. 1 liter of water. Then automatically what concentration is coming among? 1 molar concentration is coming. Number of moles by volume of solution, 1 by 1, nothing but 1 molar solution. Now I will take the solution in a beaker. Then what happening here? Plus is there, minus, plus, minus, plus, minus, nothing but Na plus Cl minus, so Na plus Cl minus, so like that will be there. Yes or no? This is the situation in this 1 liter solution. Okay, now I am explaining one more thing. Same 1 mole of NaCl I am taking in 2 liters of water. Then what happening? Number of moles by volume of solution, nothing but 1 by 2. 1 by 2 means 0.5 molar solution. Okay, if you take like this, what changes is coming? A small changes is coming, observe carefully. Plus, minus, plus, minus, plus, minus. Okay, now you take this solution carefully, you have to observe. So in case of high concentration, what happening? Na plus particles and Cl minus particles are very close together. Then between those two oppositely charged particles, what happening? Strong force of attraction will be there. Then momentum of ions will be, yes, momentum of ions is low. Automatically what happening? Conductance is low. Automatically molar conductivity will be low. No, if you take same solute but in volume will be changing, means compulsory what happening? Concentration will be changing. Means indirectly what happening? Volume is increasing. As the volume is increasing, what happening? Na plus particles and Cl minus particles are going far away from each other. Even though force of attraction will be there, but low force of attraction will be there. He is stronger, but they are weak. Because of weak, they are having little bit fast moving. So here momentum of ions will be high. If momentum of ions will be high, conductance will be going on increasing. That conductance only we are calling as molar conductivity will be high. So this is the high concentration, then molar conductivity will be low. This is the low concentration, but molar conductivity will be high. Yes, he may ask the question, how molar conductivity will be varies with concentration? Yes, you have to read the definition first. So as the concentration is decreasing, between the ions the gap is increasing. As the gap is increasing, force of attraction decreasing. Force of attraction decreasing, momentum of ions is increasing. Then conductance will be going on increasing. Means as the concentration decreasing, molar conductivity will be going on increasing. I want to tell some important things here. Molar conductivity in case of strong electrolytes. Strong electrolytes. Observe very carefully. This is very important thing. Follow the lead. How molar conductivity will be varies in case of strong electrolyte? By changing concentration. For example, strong electrolyte means what? 100% undergoing ionization. For example, I taken 1 mole of which one NaCl I taken in 1 liter or something, then we are getting 1 molar of solution we are getting. Same 1 mole of NaCl only I am taking in which one 2 liters of the solution, then we are getting 0.5 molar. Okay, from here to here what you are doing? Dilution we are doing. Yes or no? Dilution means you are adding water. Okay, while adding water, what happening? Initially it is becoming high concentration, but after adding water it is becoming low concentration. You have full clarity. What is the full clarity? As the concentration decreasing, molar conductivity keep on going on increasing. My question here, the improvement in the molar conductance will be going suddenly or gradually? Means whenever you are doing dilution, means when we are changing the concentration or when we are decreasing the concentration of the solution, molar conductance of solution will be going increasing gradually increasing. Yes, what is the meaning of gradually increasing? There is no sudden changes. Okay, means in a rhythmic way it is keep on going on increasing like this. Means we have to show like this. As the concentration decreasing, keep on means what happening? Molar conductivity will be keep on going on increasing. That change is calling as a gradual change. Why? Yes, definitely is going on increasing, but why it is happening gradual change, not sudden changes? Observe very carefully, Amma. Strong electrolyte means what happening? Here only it is involving in the 100% ionization. All taking particles is split down into ions. But you are adding water. While adding water, what happening? Whatever ions is there between them, gap is going on increasing. Then slowly momentum is going on increasing. Slowly momentum is going on increasing means slowly conductance will be going on increasing. Means the entire process will be going on gradually increasing by increasing the distance between the ions, by decreasing the force of attraction between the ions. But I want to explain in case of weak electrolytes. Yes, observe very carefully. Okay, means weak electrolyte means what? For example, you take acetic acid, you can take CH3COOH solution you taken. At 1 molar concentration you taken, at 0.5 molar concentration you taken. Means you are doing dilution. You are doing dilution means concentration will be keep on decreasing. While decreasing, compulsory molar conductivity will be going on increasing, no doubt in it. But in case of weak electrolyte, we are getting sudden changes. Sudden changes we are getting in lambda m, that is only we are calling as sharp values we are getting. A sharp change we are getting in lambda m. Why? Suddenly it will be changing, but not gradually. Why? Observe here very carefully. Initially we taken 1 molar particle. Is it completely undergoing ionization? No, we calculate this what? Extent of dissociation or ionization will be less than 100%. Now initially, for example, 80% is undergoing dissociation. Keep on doing dilution, means keep on you are adding water. What happening? Extent of ionization will be going on increasing. At infinite dilution, what happening? Suddenly 100% of almost not 100%, very near to the 100% is undergoing dissociation. At very low concentration, nothing but at infinite dilution. Infinite dilution is what? You have to take 1 spoon of acetic acid, dip it in a big tank of water. At that situation, what happening? Almost all the taking acetic acid particle will be undergoing ionization. What happening suddenly? Suddenly what happening? Ions number is going on increasing. At the same time, what happening? The gap between ions is also going on increasing. At a time, two things is going on. But here not like that. Initially ions will be same as like final ions. Just the gap is going on increasing, gradually changes is going on. But in case of weak electrolyte, initially ionization will be less. Keep on doing dilution, ionization will be increasing. At infinite dilution, suddenly almost all the particles is undergoing ionization, infinite that suddenly conductance will be increasing. That's only we are calling as sudden change or sharp changes is coming in its value because of at infinite dilation number of ions will be increasing. At the same time, the distance between the ions will be increasing. At that infinite dilation, then what happen in the conductance of that electrolytic solution will be going on suddenly increasing. That's only we are showing like this. Not gradually, suddenly at this dilation, at this concentration, what happening? It's suddenly going on, keep on rising. That's calling as sharp changes we are discussing. Is it clear? Yes. Now, how to discuss about the molar conductivity versus concentration graph. Concentrations graphs. See, this graph only he asked in 2019 board examination for 1 mark he asked. So, what is the graph representation for the changes of molar conductivity with concentration? Observe very carefully. First of all, I am taking x-axis and y-axis. On x-axis, I am taking square root of concentration times or C power 1 by 2. On y-axis, I am taking molar conductivities. Okay. First of all, I am explaining about the strong electrolytes. Imagine NaC. Okay, this is the 0.4 molar concentration, 0.3 molar concentration, 0.2 molar, 0.1 molar and 0 molar. These are the square root of concentration values. Now initially what you taken at 0.4 you taken. 0.4 means high concentration. High concentration means molar conductivity will be less. It will be coming here. Okay, still you are adding water to that one. Means you are doing dilution. You are doing dilution means concentration will be decreasing. Concentration decreasing means molar conductivity will be going on increasing because the gap between the ions will be going on increasing. So already I explained all these things. What happening as the dilution is going on or decreasing the concentration of the solution. What happening? The molar conductivity will be keep on going on increasing. Is it there any sudden changes or gradual improvement is going on? Gradual improvement is going on because only the gap between ions is increasing. That's why the gradual improvement in its molar conductivity. This is for strong electrolyte. Okay, from the strong electrolyte I want to check one important point. Okay, when its concentration is almost zero means what? Infinite dilution. Infinite dilution means you taken 1 spoon of salt, thrown in 1 big pond of water. Can you feel salt taste? Should not. Means compare with solute, solvent will be huge. Then its concentration is almost taken as 0. That is calling as, I will write here, if C is equals to 0 means it is calling as infinite dilution. Infinite dilution. Infinite dilution means solute will be very lesser compared with solvent. Then what happening at almost infinite dilution is concentration is 0. What happening? The ions are far away from almost far away. Means whatever positivity will be there, that much they are going far away from each other. Then there is no force of attraction only. Then they are moves randomly. Means then they can move very freely. Very freely means carrying conductance or carrying energy will be too much. That's only it is calling as this value. That is denoted by lambda naught m. Yes, what is the meaning of lambda naught m? When concentration is 0, the molar conductivity of electrolytic solution will be maximum. That is only we are calling as limiting molar conductivity. Limiting molar conductivity. That limiting molar conductivity is denoted by lambda naught m. What is the meaning of naught? When concentration of the electrolytic solution will be almost 0, means we have to take very small amount of the solute and a huge amount of the solvent. Then ions is maximum far away from each other. Then they can move very freely. Then conductance will be maximum. That's only we are calling as limiting molar conductivity. Can you tell the definition of the limiting molar conductivity? Molar conductivity of electrolytic solution when its concentration is becoming 0 or at infinite dilution. So now I want to study about the weak electrolyte, how they are changing. They are also going on increasing by decreasing the concentration. My question, weak electrolyte graph will be coming above or below? Weak electrolyte graph graph will be coming above the strong electrolyte or below the strong electrolyte? Below only. Why? Yes, in case of weak electrolyte, dissociation will be initially less ions, less conductance. That's why definitely for weak electrolyte, we are getting graph should be below the strong electrolyte. Now here also what happening? You keep on adding water. Keep on adding water means what happening? Concentration will be decreasing. As the concentration decreasing, molar conductivity will be keep on increasing. Okay, it's coming like this, increasing. But at this point, what happening? It's a sudden change will be coming. Yes, you have to observe very carefully. Yes, we are getting sudden changes. We are getting at almost zero concentration. Yes, I explained this point also. This only, no? Yes, at this zero concentration or infinite dilution, at a time, how many particles you are taking all are undergoing dissociation and a gap is going on increasing. Then conductance will be going on max. So this is for weak electrolyte. Yes, we have to explain very clearly. My question, okay, from the graph, for which type of electrolyte we can get the limiting molar conductivity? Yes. Why? Because if you can extend that strong electrolyte graph, it will be intersecting here. That intersecting point is nothing but at zero concentration, that molar conductivity. That's what we are calling as a limiting molar conductivity. Is it possible to find out the limiting molar conductivity for weak electrolytes from the graph? Never. It's not possible. Why? Yes, how much you can extend that? It won't touch this molar conductivity axis. That's why in case of weak electrolyte, we can't get limiting molar conductivity values from where? Graphs. From graphs. Okay, that's why we are studying further information. Did you got clarity? For strong electrolytes only we can get the limiting molar conductivity from the graph, but not for weak electrolytes. Okay, now I will explain something regarding strong electrolyte from this graph. Okay, for strong electrolyte we are getting like a straight line. Yes or no? Okay, later one of the scientists is there, Konnurs law. Actually, he is one of the scientists. He proposed one relation between molar conductivity versus concentration of the solution. What is that? Well, you see carefully. Lambda m is equals to lambda naught m minus of a into square root of c. Okay, x-axis is square root of concentration, y-axis is molar conductivity. So we are getting straight line equation like this. Is it comparable with straight line equation? Yes. Why? Variable terms is what here among? Molar conductivity changing and square root of concentration changing. Lambda naught m will be intersecting point and a will be the slope. The slope is negative. That's why line is coming downwards. Okay, y is equals to mx plus c. Yes, what is the slope of this straight line? Minus a. That's why I will write here c. Okay, rotate it. So lambda m is equals to lambda naught m minus a into square root of c. It is similar to y is equals to mx plus c. In this x and y are variable terms, but in our information square root of c and mod lambda m will be varying terms. So from this we can tell slope of this straight line is equals to minus a. This is only nothing but slope of this straight line. Slope of this straight line. So a value will be depending upon charge on cations and as well as anions. Anyway, we are taking electrolyte means neutral, no? We can take either positive charge or negative charges based on the it is depending. Okay, now intercepting point is there. That intercepting point is nothing but lambda naught m. Is it clear? This information will be very important. You have to work out very carefully. And next, I want to tell one point here, especially for competitive point of view. Okay, extent of dissociation, extent of ionization or dissociation for weaker, stronger is not a matter. Is equals to lambda m by lambda naught m. This is denoted by alpha. Extent of dissociation or ionization is equals to molar conductivity by limiting molar conductivity. Sometimes we may give equivalent conductance. It is nothing but lambda E by lambda naught E. So generally we are using this formula only. Keep in mind, to get the extent of dissociation, lambda M by lambda naught M is nothing but molar conductivity by limiting molar conductivity. Now I will tell one important formula. concept I will explain. You see, Konnurs law. Konnurs law will be there. What is this Konnurs law? I will explain. You can understand. According to Konnurs, he did so many experiments. Finally, concluded one thing. Means limiting molar conductivity. Limiting molar conductivity. Limiting molar conductivity of a particular ion is remains same irrespective of its origin. Did you understand anything? Did you understand anything from this statement? Konnurs put very important point. He did so many experiments. Finally concluded one thing. Limiting molar conductivity of a particular ion is remains same irrespective of its origin. What is the meaning of this one? Anybody? For example, just I will give you explanation. Once you check it, lambda naught of NaCl is there. Okay, from this what we can get? Limiting molar conductivity of Na plus we can get it. From this what we can get? Limiting molar conductivity of Cl. And also I will take another chemical. You take it. Limiting molar conductivity of KCl and Ag. From this what we can get? Limiting molar conductivity of K plus we can get, and limiting molar conductivity of Cl minus. What is telling now? Limiting molar conductivity of a particular ion should be remains same irrespective of its origin. Means it is coming from KCl, NaCl or MgCl2 or calcium chloride is not a matter. At infinite dilution, the chloride ion having a particular limiting molar conductivity. Here also we are getting X, here also we are getting X. Yes or no? 100%. This is same ion having same conductivity power. No alternative for that one. That's what he is telling you. But compulsory it should be in limiting condition. Limiting condition is at infinite dilution. Okay, for example, just I will give you one more thing. If you take for example lambda naught of MgCl2 is there and lambda naught of MgBr2 is there. Okay, same concept. From here what we can get lambda naught of Mg plus 2 we are getting, and as well as lambda naught of Cl minus we are getting. From here also we are getting lambda naught of Mg plus 2. From here we are getting lambda naught of Br minus. But what is telling us? Whether it is MgCl2 or MgBr2, MgI2 is not a matter. Yes, so for the same magnesium ions, the limiting molar conductivity will be remains same. Here also what? Here also why? Are you clear or no? Yes. That is an important statement of Konnurs law. According to Konnurs, what he told, the limiting molar conductivity of a particular ion should be remains same irrespective of its origin. So from this, we can give some explanation. Okay, you see, just I will write some examples for this one. Limiting molar conductivity of NaCl. How can you write? As like normal molar conductivity, can we write now? Limiting molar conductivity of which one? Na plus particles plus limiting molar conductivity of Cl minus. Okay, like that, just I will give you one more thing. Limiting molar conductivity of MgCl2 I want. As like normal molar conductivity has to, but it is at infinite dilution, is almost concentration will be 0. Okay, we can write it here. Limiting molar conductivity of Mg plus 2 plus 2 has to be mentioned or not requires? Requires, because it is a molar conductivity. Equivalent means not requires, because all ions conductivity remains same. 2 into limiting molar conductivity of Cl minus. Okay, what we are discussing, these all things we are discussing related to strong electrolyte. Okay, how can you get the limiting molar conductivity for weak electrolyte? It's not possible from the graph, but we have to get those limiting molar conductivity of weak electrolytes also. But how it is possible? That is also done correlation. How we done? I will explain. Limiting molar conductivities of weak electrolytes is also possible, but not from the graph, by using some other techniques. So possible by using limiting molar conductivities of strong electrolytes. By using strong electrolyte information, we are getting weak electrolyte information by taking origin of Konnurs point. What is that? For example, understand. I want to find out the limiting molar conductivity of CH3COOH. Is it possible from the graph? Is it possible from the graph? No. Why? CH3COOH is organic acid, weak acid, so that's why we are getting sudden changes like this. So what is this one? It is indirectly nothing but limiting molar conductivities of CH3COO minus plus limiting molar conductivities of H plus particle. But we have alternative technique by using Konnurs point. We can get this weak electrolyte information by using strong electrolyte. Tell me some chemicals which are having these ions, but those chemicals should be strong electrolyte. Yes, very good. One is HCl we can use. Okay, very good. Strong electrolyte is strong acid. H2SO4, no. Yes, we can take sodium salt of acetic acid. Salt means, yes, from this we are getting this one. Okay. And I want to take NaCl. Okay, this is strong acid and salt, strong electrolyte. This is also salt, strong electrolyte. By using this one, we are getting those ions. Okay, these values we already known from graphs. Okay, now, how you are getting this one? Lambda naught m of CH3COOH. These two ions we have to get by using these three chemicals. By doing sum and subtraction. By addition and subtraction, I want these ions by using the strong electrolytes. I will write here, see, lambda naught m of CH3COONA. From this we are getting acetate ion. We want H plus. Coming from where? HCl. So can I write lambda naught of m of HCl? Is there any problem? No. Minus. From here, acetate ion is coming. From here, Cl is which one is coming? Cl, H is coming. But we don't want Na plus and Cl minus. So what we can do? Minus of lambda naught m of over. Just simplify. You will get these two ions information. That's only Konnurs told. What we are telling, irrespective of its origin, if you have any particular ion, whether it is coming from acetic acid or sodium acetate, is not a matter. Acetate ion at infinite dimension having a particular value, a fixed value. Do this one. Lambda naught m of which one? CH3COO minus plus lambda naught m of Na plus lambda naught m of HCl is decomposing like H plus lambda naught m of Cl minus lambda naught m of Na plus minus lambda naught m of Cl. Some are cancelled here. What is cancelled here? Na plus, Na minus cancelled. Cl plus and minus cancelled. What remains here? What is nothing but limiting molar conductivity of weak acid. Can I give one more thing? For example, this is the one of the example I am giving. I will give you one more example. I want a limiting molar conductivity of NH4OH. What strong electrolyte is helpful to us? We want NH4 ion we want and OH minus we want. What can we take? Can take NH4Cl. Can we take NH4Cl means salt? Yes, na? Can we want OH minus from strong electrolyte? Can I take? Yes, very good. Lambda naught of NaOH or KOH you can take. We want NH4 plus and OH minus. We don't want NaCl. Then minus of lambda naught m of enough. These are all strong electrolyte. That information we know from graph. We can substitute here. We are getting weak electrolyte.